Hi, my name is JeNa Jibreen, and I'll be talking to you about the chemistry of apples. More specifically, the browning of apples or oxidation of apples, but apples because I love them and I eat approximately 35 of them a week. Now, apples are very nutritious and very delicious as well. They are full of many nutrients, but specifically I'll be talking about antioxidants and phytochemicals, which are what fight off things called free radicals. Free radicals are highly reactive atoms with unpaired number of electrons. And the unpaired number of electrons is the explanation as to why free radicals are so reactive, as the electrons are unpaired. And in this case, free radicals are very, very damaging to a person's bodily and cellular functions when reacting with them. So antioxidants are good when fighting off free radicals, and apples are full of antioxidants, which is another reason why apples are so fantastic. Now, in the browning or oxidation of apples, I will be talking about the brief overview of them at first and then into the nitty-gritty details. Brief overview is we have things called phenols in apples, which are antioxidants that I previously discussed. Now, phenols are the compounds, antioxidants, inside the apple, and when apples are exposed to oxygen, oxidation occurs, of course, with the help of an enzyme called polyphenol oxidase. With the help of polyphenol oxidase, oxygen works with it to change phenols into things called okinones, which are the precursor to the brown or melanin that creates the brown color in apples. Now into the nitty-gritty details of it. Here is a drawing of a cut-up apple. It's not a very great drawing, but it will suffice. Inside the cells of an apple, I show the many phenols through the dots, and then enlarge into the structure of the phenols over here. I'm going to zoom in a little bit. As you can tell, as I wrote right here, when the apple flesh is exposed to oxygen, it works with the polyphenol oxidase enzyme, of course, to change the phenols into the okinones. Now, oxygen likes to take away electrons, so as it works with the enzyme, and of course enzymes are known to speed up and help reactions to occur. It helps this reaction to occur with the oxygen liking to take away the electrons. Now, in the reaction, because PPO, the enzyme, is so prominent in the reaction, a way to stop or prohibit the browning, slow the browning of an apple to occur, is to find a way to inhibit the activity of the enzyme, because without the enzyme, the browning will not occur as quick or at all. So scientists have found ways to genetically modify certain apples to take away the PPO, inhibit the activity of the PPO, to completely stop the browning from occurring. But in a more practical sense, day-to-day usage, a way to slow the browning of an apple is to take lemon juice and put it on the flesh. The reason for that is lemon juice, vitamin C, aka ascorbic acid, of course, is very acidic. So oxygen, when apple is exposed to oxygen, an apple drenched in lemon juice is exposed to oxygen. The oxygen will react to lemon juice before it the vitamin C, before it reacts with the PPO, which will then, of course, slow the browning of the apple. As a visual of that, about an hour ago I cut up an apple, and this is the half that I did not drench in lemon juice. As you can tell, the browning has occurred, and it will get worse as time goes on. The one drenched in lemon juice, comparatively, is a very normal color. No browning has occurred, and it demonstrates it. But thank you for watching. I hope you enjoyed.